Hi, my name is Nina Wan. My project is on the effect of berberines on WNT-beta casino signaling pathway activated by deoxycholic acid in planarians. Gastric cancer is one of the most common malignancies. Gastric cancer is often overlooked because it has no obvious symptom in the early stage, mistaken for indigestion or chronic gastritis. Although gastric cancer can be treated in many ways, the 5-year survival rate for people with gastric cancer is only 32%. WNT-beta-casein signaling pathway was found to be involved in gastric cancer. It played an important role in regulating proliferation, stem cell metastasis, and homeostasis in normal gastric mucosa. Dysregulation of the WNT-beta-casein signaling pathway is associated with tumor cell proliferation, survival, metastatic ability, and may lead to the recurrences of the tumor. Study has shown that blocking the WNT-beta-casein signaling pathway can inhibit the growth and phenotypic characteristic of cancer cells. Compared with normal cancer tissues, WNT-beta-casein signaling activity is enhanced in malignant cancer tissues. Planarians are known for their powerful regeneration ability. When activated by WNT-beta-casein signaling pathway, could increase regeneration in tail fragment. Deoxycholic acid is associated with the development of cancer and could also activate the beta-casein signaling pathway. It promotes the formation of cancer and simulates colon cancer's invasion through activation of the WNT-beta-casein signaling pathway. Berberine as a high-safety medicine, well-targeted drug for the treatment of cancers. It could trigger apoptosis, inhibit cancer cells' growth, and catch the cycle of the cells. Research shows that berberine could inhibit the migration and invasion of gastric cancer cells, including through the WNT-beta-casein signaling pathway that plays a role in invasion of those cancers. This experiment seeks to utilize deoxycholic acid activated the WNT-beta-casein signaling pathway by simulating increased cell proliferation and evaluate regeneration time and locomotive ability of berberine to be used as a treatment that could deactivate the WNT-beta-casein signaling pathway. Before any experiment, Panera's were stored for 7 days and were placed in different solutions as fresh spring water is controlled. 50, 100, and 400 micromolar berberine was diluted from 5-gram berberine stock solution, and 550, 100 millimolar deoxycholic acid was diluted from the deoxycholic acid stock solution. To test the regeneration rate of the Panerias were put in different concentrations for 3 days, and they were cut into 3 sections as head, trunk, and tail. The plasma will be shown after the Panerias obtrusion. Regeneration completed when the Panerias are properly proportionate, and the body pigmentation is homogeneous. Each concentration had 3 replicates. To test Panera's locomotor velocity, Paneras will have tutored in their respective test substances or combination at appropriate concentration for either 2 minutes or 1 hour. Monitor for 3 minutes by crossing the number of grid lines across. All data were analyzed by students' t-tests and one-way analysis of viruses. All concentrations tests significantly decrease locomotive velocity. The 5 micromolar deoxycholic acid before application for 1 hour and 100 micromolar deoxycholic acid after application for 1 hour had the largest decrease in locomotor velocity by over 30%. Under all berberine concentration, the locomotor velocity of Panareus after activation was significantly decreased, where 400 micromolar berberine decreased about 15% of the control locomotor velocity. Surprisingly, under concentration, the combination of berberine with deoxycholic acid showed a significant decrease as compared to 50 micromolar deoxycholic acid and a restoration compared to controlled, where 50 micromolar deoxycholic acid with 400 micromolar berberine, the regeneration rate under deoxycholic acid concentration was present. The regeneration rate of Panareus tails was significantly increased under 50 micromolar and 100 micromolar deoxycholic acid. This supports the Walter's research in 2020, showing that deoxycholic acid might have activated the WNT beta casino signaling pathway. The regeneration rate under berberine concentration was present. The regeneration rate of Panareus tails was significantly decreased under 50 micromolar, 100 micromolar, and 400 micromolar berberine concentration, and the regeneration rate of Panareus tails was significantly decreased compared to 50 micromolar deoxycholic acid, suggesting that berberine had been successfully in reversing the effect of deoxycholic acid activate WNT beta casino signaling pathway, which had been implied in cancer progressions. Deoxycholic acid slowed down the tail's regeneration of Panareus through WNT beta casino signaling pathway and was activated. 50 micromolar DCA reduced the time it took Panareus to regenerate by 50%. 400 micromolar berberine extended the tail regeneration cycle of the Panareus by 50%. After activation of the WNT beta casino signaling pathway in Panareus by DCA, berberine can effectively inhibit and restore the growth cycle of Panareus to close to its original cycle. Both DCA and berberine inhibit the locomotor ability of Panaria. However, activation of WNT beta casino signaling pathway has previously been reported to promote motor recovery after simulated treatment of spinal cord injury. After activation of WNT beta casino signaling pathway in Panareus by DCA, berberine can also effectively bring locomotor ability of Panareus close to normal. Although the results suggest that deoxycholic acid can activate WNT beta casino signaling pathway, future investigation of DCA is needed in gastric cancer. Future research is also needed to determine whether if there is a direct interaction between the berberine and WNT beta casino signaling pathway. Deoxycholic acid can activate the WNT beta casino signaling pathway and act as a molecule switch to specific tail phase in Panareus. Berberine was effective in inhibiting regeneration, which may suggest interaction with the WNT beta casino signaling pathway. Thank you for watching.